Welcome to the Institute's full-scale bogie rolling contact rig called Harold. Harold was designed to represent as closely as possible the contact between a railway wheel set and the rail. What you can see down here is a 2-metre diameter roller. The roller can rotate at speeds up to 200 kilometers per hour, and we can manipulate the bogie on top of the roller using this movable platform which the bogie sits on. The platform can be moved laterally. It can also be rotated about the centre of the railway wheel set to recreate the curving conditions which we see on a real railway line. That enables us to study aspects of rolling contact fatigue, traction and braking, so helping the railway industry reduce costs and maintain safety. We can also measure in detail the forces generated between the wheel and the rail using these load cells which you can see here. These measure the forces in the lateral and the longitudinal directions, and enable us to collect lots of data which we can use to study adhesion and the braking performance of the vehicle. Beneath where I'm standing now, there's also a wheel lathe. This enables us to change the rail profile on the rollers to represent different railway infrastructure. So for instance, in the UK, we've used this for London Underground and Network Rail profiles. In the future, we'll be developing Harold to Harold 2.0 later this year, whereby we'll be able to introduce a traction motor to the bogie. This enables us to study regenerative braking, whereby the motor is acting in a braking mode to capture energy and restore that back to the bogie to save energy. We'll also be able to study the effect of braking on the motor performance. So that introduces a whole new area of research for the Harold test rig.